Well, we're still waiting for a quote for the discs, so we can't do anything on that right now. So we're going to do something else. I'm a bit upset. I need to look for another supplier because apparently this guy doesn't want to sell anything to me. Well, that's what you have sometimes. He's very close. That was the only reason why I was trying to get something from him, but apparently he doesn't want it. There is more to come, but he lost it now. I'm done with him. We'll see. I got another company which is probably about 5 miles away, 10 miles away, I don't know. A bit more expensive. I know that for sure because they're bigger, but they are very quick and very reliable. So let's try those guys, because I need to get on with these rollers here. So in the meantime, we're gonna work on another piece, which is also for the project. These are worn out parts I got actually from the scrap container. They need a bit of work, obviously. That has a lot of surface rust. It needs to be skinned both sides, and it needs to be the same thickness everywhere. I probably use either the Clarkson or the tool post grinder to get it to size, because the thickness is critical. It has to run concentric, and it has to be the same thickness at all time. The run out is going to be minimal, because as you might see these marks here, this thing wasn't running through anymore, so it was rubbing. Could have other issues, bearings or whatever. So what we're going to do is skim these plates. That's how the other side looks like. I've got 2 of them. And then we do the rotor. The rotor goes in the middle here. And then we need to make a shaft. Some cover plates, bearings. Bit of work, but it should be fit for purpose. As with all the other stuff, I'm not going to tell what it is right now, but someone may have an idea what that might be. Anyway, let's check what it is dimension wise. We also need to make a spacer which goes here. It's got to be non-steel, either non-magnetic stainless or aluminium. Brass is a bit too expensive, because usually they are made from brass, but I don't have something in that size. Anyway, as long as we get it running through within a hundredth of a millimeter, it's fine. We do the same with the others. They are not ideal because they have seen some temperature here. They turn blue a little bit here, but yeah, for what we do with, it's okay. I wouldn't give that to a customer, but for our own purposes, I think that's fine. So we scrape the surface here, just to get rid of the rust spots, and same here. And we measured it, and it's the same. Can't see it really, but it's the same distance on everywhere, so we can use that surface to indicate. What we're going to do first is we'll machine this side flat. We indicate that one, and then we machine this side flat, and then we do the other side. On this one, same as this one, you can see there are some hot spots, so there was rubbing, which is no good. So we do a very light skim here, get rid of the rust and all the warpage, if there is any. And also we skim this a little bit just to get rid of the rust here, because it was leaking apparently at this point. So doesn't need much, we'll see. But this is our reference surface. we can indicate. That was the most important thing. They have something to indicate, because it's gonna be parallel both sides. Anyway, let's get to the light. I think we got it fairly well dialed in. I would say it's 1 or 2 hundredths of a millimeter. It's just when you start off, it's gonna, you should have greased the surface. We're gonna be careful. I think these inserts are hard, so there is a bit of material left. We can't skim a lot of it. So we're in the last part. It's just about cleared off. There is a little bit of rust left on the outer diameter, but yeah, I think we can lift it up. As long as we get it watertight, it's okay. Yeah, it's good. I can't go any deeper because I'm not going to hit the inserts for the screws. So it is what it is. It was crap already, so we just make some use of it. And that's going to be it now. Alright, let's stop that and have a look. Pretty tight there, but just about clear. Well, we got some little marks left here, but yeah, it's still, it looks rusty, but yeah, it's pitting. There's nothing you can do. I think it was leaking before, so it was leaking out there, but I think we got enough surface, and we can always put an O-ring in that corner. I have some ideas about that. We want to make that as much as possible contact to the core plate, to get the heat away. Alright, that's going to be it from this side, and let's do the other side. So we got it dialed in as best as we can. We got about 100 plus minus, but there are some rusty spots still. It's fairly flat. I think the outer surface looks like being nickel plated or so. That's what it looks like. There is some plating on it. You can see it here. Could well be there is some nickel on it. Who knows? We're gonna machine that flat. It's got a lot of warpage, I can see that. If I go further out, it's actually a banana. So we just skim it flat, whatever we need, and then we give that a skim as well, because that is actually the wedge surface here, so you wedge it together to get the distance right. Yeah, that's what we're going to do. So we make that flat and see what we get. I'm strange with that plating here. Feels like plated. Alright, anyway. So it used to speed a little bit, because it was a bit too much. It's the maximum speed in back here, and it's interesting. There's quite a bit of a cut on the outside, but on the inner diameter there's almost nothing. So it's pretty warped. So just make it flat and then we'll see. Let's run that through, and yeah, you can see. Look at the surface. It's pretty warped, and the cut is getting less and less and less in the center. So the whole thing is actually belly shaped, which you don't want. You want it flat. Alright, that's got it. So hopefully that's our final cut. Maybe not. It's about 300 of a millimeter to get this cut. So yeah, I can hear there's still some voids. We'll see how it works. It's pinning off quite a bit, but I guess in the center it's still 4. Alright, let's see. So we decided to do another final pass with a bit of a higher speed and less speed. Hopefully that makes the surface a bit nicer. It's okay, but it's not super smooth. I think I got a bit of play in the thrust bearing, and in back gear there's a lot of vibration because when you run on the small pulley, that joint of the belt is hammering. So hopefully that's getting a bit better now. It looks actually better, so we'll see. Again, the surface quality is not super critical as long as it's flat. Alright, we'll come back when we're done. Well, apparently carbide tooling needs speed. Looks a lot better. We get some glowing chips here, but that's how I get a decent finish here. I'm running about 600 RPM or so. A bit too much on the outer diameter, but I'm not going to change it because it's a really nice mirror finish, and that's the only way I get a decent finish here. Glowing chips here. Okay. As we can see, carbide tooling needs speed. Super mirror finish. Yeah, high speed. That's what it needs. There is one mark here and one mark here, but that's the machine, I think. It's just an old worn-out machine. I'm gonna live with that, but I can live with that surface finish. Feels good. So we'll do the outside diameter, make sure that's all good, and then we're done with this, and we're gonna do the other side, or the other plate, and then we're gonna do the rotor. That's probably a bit more challenging. I think I've fit it to the shaft and machine it then, so I know it runs absolutely straight with the shaft. Anyway, that's it for now. I'll see you in the next part. Thanks for watching. Thanks for subscribing. Until next time.